Alright, ladies and gentlemen, we're going to work today on page 149 in our Learn book. Our objective for today is to kind of take a lot of the things we've been talking about with quadrilaterals, these two-dimensional shapes, basically see how it all applies to a square, talk about these different attributes some more. We're also going to practice using our tools. And by tools, I mean a protractor, which, again, hopefully you either have or you've printed one, and a ruler, which you hopefully have or have printed one. Because if we use the tools correctly, we're going to draw a very specific shape. It's going to be completely accurate, and it'll help us when we're answering these questions down below. Now, you can do this in the book. You can do it on a piece of line paper or blank paper. You may have also noticed I actually tore my page out. I never like to tear my pages out. But for this one, I think it's going to be helpful. Okay? It's up to you how you want to handle that. Please follow along with the video. Make sure you're doing what I do with me. If you need to pause to take a moment to do it, that's fine. But I do want to complete this activity together. So please make sure you're following along. We're going to start, and you can kind of see the outlines. I've sort of practiced a little bit already to see specifically what will work best. We're going to start with a point. I'm going to put it a little higher than it was originally. Point A. This is going to be one of the corners of our square. This is going to be one of the corners of our square. We are going to build out from point A. Now, easiest thing to do is just to put a side on it. So I'll use my ruler. I'll line up the zero edge with A. There we go. I'm going to go out to about 3 inches. So I'm going to put a little line there to show. See, it's over a little bit. Sometimes it's a little hard when I'm doing it at the angle for the camera. There we are. That looks better. Let's go ahead and connect those two. Okay. All right. So this is exactly 3 inches for real and for true. Let's say this is point B. Now, seems easy enough, right? Let's just go straight down and do another side, but we do want to be very careful because we are literally going straight down. We have to make 90-degree angles if this is going to be a square. So, I'm going to take my protractor, and this is why I tore my paper out, so I'm going to have to turn this around a little bit. Okay. You can start with A or B. It doesn't really matter. I am choosing A. I'm going to take my protractor. Now again, mine has this little line. That's what I am going to line up with my point. Some of you, you have something different. You have a little hole. If there's a little hole, you're going to put the hole right over it. Okay. Now either way, once I do that, I need to try to get the bottom edge of my protractor lined up as best as I can with the side of the square. And you can actually see where that zero line is. There we go. Now it's under there. Okay. Now, since I want a 90-degree angle, I count up from 0, 10, 20, 30, 40, 50, 60, 70, 80, and I find 90 right here. Okay. A little line there. Now, I am going to connect these two. And I already know that when I connect them, just by looking at them, I can tell it's going to be a little longer than 3 inches. So I'm going to do this very lightly, because all I want is to make sure I have the straight line between the 2 points. Then I'll use my ruler, get a little more specific, and actually, wow, that was actually not too bad. I was sure that it was going to be significantly longer, but it's pretty close. Let me go ahead and darken in the line. There we go. And I'll put one of my little corner boxes in here to show that that's 90 degrees. Okay? So we've got 2 sides so far. They're both exactly 3 inches. I'll erase this little extra bit. Don't need it. Okay? Now I've got 2 options. I can work from this point or this point. Doesn't really matter. I need to measure a 90-degree angle again. So I'll go from this point. All right, it's fuzzing out. There we go. Okay. Watch me. We'll do it again. Line up the point. Make sure the line is on the 0. And if you're not sure what I mean, I'm talking about this right here. This line right here matches up the side of the square. There's my 0. Yes, 180 also, but because my angle is going to be on the inside, I want to use the smaller numbers. All right, same thing. Let's put a mark here for 90. Make sure that's pretty good. Probably won't be as far off as I thought it was going to be. I'm going to take a little bit of a shortcut. I'll line up the 3 inches right here. Line that up. There we go. And we'll just get the side in right there. Okay. All right, once it focuses, hopefully we'll see, looks pretty decent. Okay. Here's another right angle. Now, if I did this whole thing correctly, I should be able to measure from this point to this point, and it should be 3 inches already. I should be done with my protractor. If those other two are right angles, then this is also. Yeah, that looks pretty good. I feel like maybe it's a hair too low, but it'll be just fine for what we're doing today. Okay, so here's our square. Here's our square. Hopefully it looks pretty good. Maybe not as perfect as it could be, but I think it's satisfactory. Go ahead and straighten that out a little bit. There we go. Okay, so here's our square. Now we can go through and use this to answer some of these questions. A, because a square is a kite. Now, we talked about kites. Okay? A kite is something that has two adjacent sides that are congruent, and then the other two adjacent sides are congruent to each other. So this pair is congruent, this pair is congruent. Now, technically, that's true here, isn't it? If I finish labeling my square A, B, C, D, AB is congruent to AD. BC is also congruent to CD because every single one is 3. If I take my square and twist it, it looks a little more like a diamond, looks a little bit more like a kite. So this question says, because a square is a kite, it must have what a kite has. It must have two pairs of congruent sides. A kite has two pairs of congruent sides. One pair, two pairs. Well, a square must have the same thing, and it does. 3 inches and 3 inches, 3 inches and 3 inches. Okay. Because a square is a rhombus. It's true, it is a rhombus. What makes it a rhombus? Well, a rhombus has all sides that are congruent. That is the one big thing that is unique to a rhombus. Now, all the properties of parallelogram, well, so does a rectangle, so does a parallelogram. The one thing that is special to the rhombus, all sides are congruent. When we talked about the kite, we really only have one big attribute we talk about with the kite, those two pairs of congruent sides. We're looking for the uniqueness. We're looking for what is only true of, in this case, a rhombus. Okay? It must have all congruent sides. And this kind of overlaps up here. We got one pair of congruent, we've had a second pair of congruent. It just so happens that they're all congruent to each other also. Okay, letter C. Because a square is a rectangle, it must have, okay, what is unique to a rectangle? Now, a rectangle might have congruent sides, might not, a lot of other things, but the one thing that a rectangle must have, it must have four right angles. Because a square is a rectangle, and every rectangle has four right angles, then the square, it must have four right angles. That is unique to a rectangle. That is unique to a rectangle. Parallelogram does not need that. Rhombus does not need that. Rectangles need that. Because a square is a parallelogram, it must have, okay, the one thing that's unique in a parallelogram. Two pairs of parallel lines. That's why we call it a parallelogram. It has two pairs of parallel lines. And if you look at a square does as well. I'm going to pick up the pace a little bit because for letter E, because a square is a trapezoid, it's basically the same, except trapezoids have one pair of parallel lines. That's what makes them unique. And really, okay, fine, well, it's got one pair. Here's this pair. AB, is parallel to CD. There you go, trapezoid. The fact that AD is also parallel to BC, that second pair, bumps it up from trapezoid to parallelogram. And then finally, because a square is a quadrilateral, the one thing that makes a polygon a quadrilateral, the only thing that is unique to just the word quadrilateral, it must have four sides. Now we worked a little bit backwards, but this is why a square is such a special shape. A square has pretty much every attribute of every quadrilateral. It has four sides, duh. It has one pair of parallel lines like a trapezoid. But then it also has a second pair, so two pairs total, just like a parallelogram. Added to that, it has four right angles, just like a rectangle. All of the sides are congruent, just like a rhombus. And then finally, like a kite, we have one pair of congruent sides, a second pair of congruent sides. And really, we didn't have enough space, but let's go ahead and put it in because it is kind of important. Not just that the sides are congruent, but that they are congruent adjacent. Adjacent sides. They're next to each other. Two pairs of congruent adjacent sides. All right. Thank you for following through. This piece of paper, whether it's in your notes, whether it's in your book, if you tore it out, keep it safe and keep it handy because this, along with this, we're going to be using these next week as we go through and talk about different quadrilaterals and talk about how we classify them. I want to give you a little more opportunity to do that. So for right now, we're all finished. If you have any questions, make sure that you email me. Otherwise, put them on a sticky note and I will see you in class. Thank you, ladies and gentlemen.